Stop. Before you scroll past this, I need you to know something that most people get completely wrong about our solar system. We always talk about Earth like it's this incredibly special, dense, heavy world. And yes, it is the densest planet in our solar system. But there is another planet sitting quietly in the darkness, one that barely gets mentioned in classrooms, one that most people cannot even locate in the night sky without help. And yet this planet is so remarkably dense that it sits right behind Earth in the rankings. Scientists are genuinely puzzled by how this happened. And the answer rewrites everything you thought you knew about how planets form. The planet is Venus. Yes, Venus, the second densest planet in our entire solar system, with a density of approximately 5.24 grams per cubic centimeter. Earth holds the top spot at around 5.51 grams per cubic centimeter. Those numbers are extraordinarily close. And that closeness is not a coincidence. It is actually one of the most fascinating and deeply studied mysteries in planetary science right now. Here is where things get genuinely strange. Venus is almost Earth's twin in size. Its diameter is about 12,104 kilometers compared to Earth's 12,742 kilometers. Its mass is about 81.5% of Earth's mass. Its surface gravity is 90% of what you feel right now standing wherever you are. If you stepped onto Venus, assuming you could survive for more than 2 seconds, which you absolutely could not, you would feel almost at home in terms of gravitational pull. And yet, Venus is one of the most violently hostile environments ever documented in our solar system. The surface temperature on Venus averages around 465 degrees Celsius, which is 869 degrees Fahrenheit. That is hot enough to melt lead. And here is the pattern interrupt moment that most documentaries completely skip over. Mercury is actually closer to the Sun than Venus, yet Venus is dramatically hotter. Let that sink in. The planet farther from the Sun is hotter. This happens because Venus has an atmosphere composed of approximately 96.5% carbon dioxide, creating a runaway greenhouse effect so extreme that the heat gets trapped with almost nowhere to escape. It is the greatest example of climate catastrophe in our cosmic neighborhood, and it should make every conversation about Earth's atmosphere feel incredibly urgent. Now back to the density question, because this is where the science becomes genuinely exciting. Why is Venus so dense? The leading scientific understanding is that Venus, like Earth, formed with a significant iron and nickel core. Current models suggest Venus has a core radius of somewhere between 2,900 and 3,500 kilometers. Unlike Earth, however, Venus does not appear to generate a significant global magnetic field. Earth's magnetic field is produced by the movement of molten iron in its outer core, a process called the geodynamo. Venus seems to lack this active process, and scientists still debate why. Some researchers propose that Venus's core may have already solidified, or that its rotation, which is extraordinarily slow, taking 243 Earth days to complete one rotation, plays a role in suppressing this geodynamic activity. Here is another detail that breaks people's brains when they first hear it. Venus rotates backwards compared to most planets in our solar system. If you were standing on Venus and somehow survived to watch a sunrise, the sun would rise in the west and set in the east. And because of how slow that rotation is combined with how long Venus takes to orbit the sun, about 225 Earth days, a single day on Venus is actually longer than its year. One Venusian day lasts approximately 117 Earth days. A year on Venus ends before a full day does. Wrap your mind around that. The density of Venus also makes it critically important in ongoing space exploration discussions. NASA's Da Vinci mission and Veritas mission were both proposed specifically to study Venus more deeply, with Veritas facing delays, but Da Vinci moving forward in planning stages as of recent years. The European Space Agency also approved the Envision mission, planned to reach Venus sometime in the 2030s. The global scientific community is coming back to Venus with serious resources and serious questions, because understanding why Venus is so Earth-like in density and yet so catastrophically different in every other measurable way could help us understand the long-term fate of Earth itself. Some planetary scientists have described Venus as Earth's evil twin, same birth region of the solar system, Similar materials, similar size, similar density, and yet an outcome so radically different that it serves as a cautionary model for what happens when atmospheric chemistry spirals beyond control. The pressure on Venus's surface is about 92 times greater than Earth's surface pressure. That is equivalent to being nearly 1 kilometer deep in Earth's ocean. What makes Venus even more compelling right now is a 2020 announcement, though still debated and under intense scientific review, that suggested possible traces of phosphine gas in Venus's atmosphere. Phosphine on Earth is associated with biological processes. The scientific community has not confirmed this finding, and the controversy around the data continues. But the fact that it was even proposed and published in a peer-reviewed journal tells you how seriously Venus is being taken as a subject of investigation. So the next time someone asks you which planet is most like Earth, the answer is not Mars. Mars gets all the attention. Mars gets the rovers, the movie adaptations, the colonization fantasies. But the planet that shares Earth's density most closely, the planet built from the most similar raw materials, the planet that could be described as Earth's closest mirror, that planet is Venus, sitting at second place in density and first place in planetary mystery. Follow for more facts that completely change how you see the universe around you. Now here is the question I want you to answer in the comments below. If Venus and Earth formed from similar materials and in a similar region of the solar system, what do you think is the single biggest reason their outcomes became so dramatically different? And does it concern you about Earth's future?